Okay.
We'll make it there. Okay.
Okay.
Good
Sorry
deal. I'll
about
let you
this
just take it
technical
away. Yeah,
difficulties.
we're running late, so I'll let you take it away. And
Okay, I'll try to stay on time and speed up as much as I can. So thank you for the opportunity to present on our project, which is intended to develop an MJO teleconnection diagnostics package. And as you can see, this project is a collaboration of a large group of people. And I am merely presenting on behalf of all of these people. So the idea of this diagnostics package was motivated by a paper that we published a while ago, in which we were interested in evaluating the advances in the prediction of the MJO teleconnections in the S2S forecast systems, and we looked at the models that are in the S2S database. So in our study, we collected and applied new diagnostic for evaluating the prediction of the MJO teleconnections and models' ability to tap into this source of predictability. These diagnostics were divided into the so-called tropospheric and stratospheric pathways, followed by the driving mechanisms of the teleconnections. We also, another small goal of our paper was to make some recommendations, but that will not be part of my presentation. I don't have time to show you figures with the diagnostics, but I want to summarize them here in this slide. So for the tropospheric pathway, we've been looking at some diagnostics based on the Z500, and this includes the stripe index to the northern and southern hemisphere, the pattern correlation coefficient to the PNA region, the relative amplitude of the teleconnections. We also looked at the teleconnections to the storm track in the northern hemisphere, and this includes the eddy kinetic energy at 800 hectopascals, and also some pattern correlation of the storm tracks versus the Z500 pattern correlation. And we also looked at the teleconnections to the 2-meter temperature, variability in the 2-meter temperature over the northern hemisphere, and that also includes some pattern correlation coefficient. For the stratospheric pathway diagnostics, we looked at 500 hectopascals because that's also a level relevant for this pathway, and we looked at the climatological position of the tropospheric vortex, what's happening over the polar cap, and the geopotential height in terms of the zonal wave number 1 and 2 of, over the high latitudes. 100 hectopascals, we looked at the meridional heat transport, mostly for the zonal wave number 1 and 2 between 40 and 80 north, and also geopotential height over the polar cap. And finally, at 10 hectopascals, we evaluated the zonal wind at a particular location, that being 60 north. So after we published this manuscript, we were contacted by many groups wanted to apply these diagnostics, but these diagnostics were not available into a package. So thankfully, we got some funding from NOAA, and we started developing this package. And for the remainder of the talk, I want to show you where we are with this package. So the idea of the package is to have a graphic user interface, and it will not be very easy for me to show you a demo, so I copy and paste the screens of our user interface here. So I will walk slide by slide. So this is how we envision that the package will start. Everything is Python based. Even the user interface is not HTML or other software. So everything is based on package on Python. So we are so in the first steps of the graphic user interface, we will collect information about where the data is located, what dates, what dates the user wants to analyze, how long is the forecast, how many ensemble members, how many initial dates. We need some information about these initial dates. And we offer the users the possibility to validate the model against ERA interim and IMERG for precipitation. We extended the diagnostics that I showed you to include some precipitation diagnostics. And also, if the user wants to use their own data set, that is also being possible. So after this is how this interface will look like. And on the left-hand side here, you probably cannot see my mouse. We will provide guidance on how this information to be entered and what we are looking for. So then one important component of all of these diagnostics is to have the RMM index, because that's what determines the phases of the MJO, and these teleconnections depend strongly on the phases of the MJO. And yeah, we also want, if the user wants to compute the daily anomaly, we can do the calculation. If the data that is already provided by the user is in the form of anomalies, they don't need to, they can skip that step of the calculation. And then again, if the RMM index is the, to be used is the one that comes with the package, which is the one available in the S2S database, then no calculation is needed, but the users also have the option to run this, to do the RMM calculation. And again, on the left-hand side of the screen, there will be information of what this radio buttons means. So the next, after this information is collected, the users have the option to select what kind of diagnostics they want to, are interested, because we cover a large spectrum of diagnostics. And if someone is interested in having all of them, just select the first button, select all, and the calculation will be done by for all of them. But if the user is interested only in a limited number of diagnostics, will have the option to select what diagnostics they are interested. So for example, if we are interested in calculating the stripes index for precipitation or the surface air temperature, then the user in the next window, the user is required to provide the names of the data files that contains the variables that are required for this diagnostic. So the first part here on the right-hand side that says project C10, that is carried over from the previous window, but then the user will have to enter, in this case, since I am working with UFS, is UFS and precipitation, and also 2 meter temperature. So then, for example, if the user, going back to the RMM index, if the user wants to calculate the RMM index, I select the wrong button here. Oh, here it is. Then a new sub-window will open, and the user will be required to provide the names and the path of the data files that are required to calculate the RMM index. So then at the end, the user has the option to select the results that wants to look at. And in this case, since we had only 2 indices that have been selected for the calculation, the results can be will be displayed only for these 2 diagnostics. this is the part that we are still working on, what will happen after the results are being selected, but we envision that, so our design is that there will be windows with plots that could be compared side by side. So for example, we will have these diagnostics calculated for week 1, week 2, week 3, week 4. So the user will have the option to have multiple windows and look at the evolution of these diagnostics, or if some diagnostics are calculated for all MJO phases, and the user will be able to select what phases is interested in looking at these diagnostics. And we also intend to allow the users to download the figures that they are the most interested in looking at them, or putting them in a presentation, or in a publication. So in terms of the overall design of the package, so it will have the workflow consists of a part that's user input, and as I explained to you here, we will have the file, the paths, the names, the data to be used for validation, the diagnostics to be computed. And then after this is it's being, all this information is being collected, then all this information is being generated into a YAML file, and then this YAML file will be used by a Python driver, and this Python driver has all the calculations embedded in it. So this design, I think, has a big advantage, because users who are very advanced, they may not need this first part with the graphic user interface, so they can go directly to the YAML file, the configuration file, and provide all this information that was collected by clicking buttons directly, and then have the ability to run the Python driver. And another advantage of this is that this is part of the diagnostic package could be also plugged into MedPlus, for example. This is something that we will be exploring, and or any other diagnostic or verification methods or packages that other groups are using by manipulating this config file and the Python driver. Also, the advantage of this Python driver is that any new diagnostics can be very easily brought into this, just by adding them to the Python driver and making sure that they are correctly making use of the the configuration YAML file. And then at the end, this is this third part, which it's the part with that will display the results. And like I mentioned, this will have two large components, will be graphics and also the graphic files. And we are also exploring the possibility to have some of the data being downloaded. And for example, if the user applies this diagnostic to three models and want to plot some of the results combined for the three models, they will have the data available and make their own figures by taking the final result from the diagnostic. Also, this by having these parts separated, we will also be able to design to add at some point in the design of this workflow a button where the user will only look at the results without doing the calculations. It's, let's say, calculations have been done on Monday, but it was not enough time to look at them, because it does take some time to do all of these calculations, and then we'll decide to look at the results on Tuesday and so on. We are testing this package, this workflow, with different S2S models. So the expectation is to work with a lot of models, not only with the UFS that we are currently testing the most. So I hope I managed to save some time and also give you some time to ask me some questions. And also, I think the intention of this presentation is also to collect some user input, because this package is intended to be available to the large community. So your input is very valuable to this. Thank you.
Great, thank you, Christiana. I don't see any questions right now in the document. I think, let's see, anything else? Let's see anything. Do you have any timeline on like when it might be available to the general community?
So
Okay,
we are
I realize it would be a guess.
Yeah, we just began the second year of the project, so probably will take an extra year to have this ready, but I anticipate to have some I don't know, alpha or beta versions available earlier, so the community can test them.
Great. Yeah, that was my next question. If you're going to have like a version available and people to use and give you some feedback. So,
Yeah, that would be great. Yeah.
yeah.
Yeah, I also have a quick question.
Please go ahead.
Go ahead.
Yeah, sure. So is there any application for using MJO teleconnection to determine atmospheric river in the West Coast?
We don't have currently a diagnostic for the atmospheric rivers, but if there are users who have these diagnostics and are interested in adding it, we are more than happy to add that. The precipitation diagnostic that I mentioned is based on the stripe index. So stripe index it's a measure of the global teleconnections to various fields, regardless of the MJO phases. So we will look at the global teleconnections of the MJO to the precipitation fields, but not particularly to the atmospheric rivers.
Okay, thank you.
You're welcome. Okay, thanks again.
Okay, I'm not seeing any other questions. So coming up on the top of the hour, if you come up with any questions, go ahead and put them in the discussion document there. and we'll make sure that actually for either speaker, we'll make sure that the speakers do see them if we see any questions go in there. So I appreciate everyone's attendance today. We'll have some more talks next month. I apologize for some of the change up on the order of the speakers and so forth, and some of the difficulties we had getting them in and available for to do the presentation. But anyway, hope to see you all next month, and thanks again for attending. Thank you especially to the speakers for their great talks today.
Thank you.
Thank you.
Thank you.